at this point, what chapter would be complete without the consideration of the, potential formulation with the magnetic charge? Oh my goodness, what a mess. Okay, so develop the potential formulation for electrodynamics with the magnetic charge, equation 7.44. Hint, you'll need 2 scalar potentials and 2 vector potentials. Okay, use the Lorentz gauge and find the retarded potentials generalizing equations 10.26 and give the formulas for E and B in terms of the potentials. Okay, so generalizing 10.2 and 3. Again, we've seen what Maxwell's equations are with the magnetic charge. We just have to put the ρm term in and the JE term in, or JM term in. So we list them there. And if there were only electric charges and currents, then the usual potential formulations apply, with E equal to negative gradient VE minus AE dt, and then B is equal to the curl of AE. But if there are only magnetic currents and charges and currents then the divergence of E goes to 0, divergence of B goes to mu naught rho m. The curl of E goes to mu naught Jm minus dB dt, and the curl of B goes to mu naught epsilon naught dE dt. Okay, so with the first equation, equation 1 says that E can be expressed as the curl of the vector potential, which of course we see E is the negative curl of AM, and plugging into 4 yields B curl of B plus mu naught epsilon naught dAm over dt equals 0, tells us that the quantity in the parentheses is represented as the gradient of a scalar. And so what we see here, since the curl of a scalar is 0, the curl of a gradient is 0. I don't know what I'm going on about. B is equal to the negative gradient Vm minus mu naught epsilon naught dAm dt. Putting these 2 together, and to 2 and 3 we yield box squared Vm is equal to negative mu naught rho m minus mu naught epsilon naught d by dt, divergence Am plus dVm dt. Similarly, we have box squared Am is equal to negative mu naught Jm plus del operating on divergence of Am plus dVm dt. All right. The Lorentz gauge for the magnetic potentials is divergence Am is equal to negative dVm dt, and that kills the terms in the parentheses, so we like that. In general, if there are both electric and magnetic charges, the currents present, then the fields are the sum via superpositions. Okay, we like superposition, so I'll let you read that. We have the gradient of VE and the time derivative of AE with the curl of AM. B, again, by analogous. We have M, VM, AM, and the curl of AE. Similarly, again, for the unit's sake, choosing the Lorentz gauge, we have divergence AE is equal to something dVe dt, just to make units match. Similarly here, the divergence of AM is equal to negative dVm dt. Okay, so Maxwell's equations become, in terms of the potentials, that box squared, which is the D'Alembert operator. We saw that earlier. So we're looking good there. Everything's checking out. And then finally, the retarded solutions are as such: VE, VM, AE, and AM. Pretty quick extensions of this, I would say, but, this has to be talked about, of course.